5 eras in the life cycle of the universe. The universe we live in is so vast that it's easy to forget it has a lifespan like most things in our environment. Only in this case, its lifespan is so far beyond all comprehension that we take it for granted. We never consider that it's evolving like we are, but on a massively different scale. In the book entitled, The 5 Ages of the Universe, Inside the Physics of Eternity, these 5 eras of the universe were first proposed in 1999 by Gregory Laughlin and Fred Adams. These 5 eras are fascinating, and they give us a way to discuss and benchmark the future, present, and past life of a given universe. While describing the phases of the universe is not a new thing among scientists and astronomers, many in the profession have embraced this particular set of eras. Number 1. Primordial Era. The Primordial Era is where it all begins, representing the birth of the universe. Although trying to determine what came before its inception, and how it came to be, remains to be seen. As we all know, its birth started with the Big Bang, which took place around 13.8 billion years ago. For just a brief period, the laws of physics including spacetime were believed not to exist. This interval is called the Planck epoch and supposedly lasted for 1/10 seconds, or 10 million of a trillion of a trillion of a trillionth of a second. Within this briefest of time, the Big Bang occurred with a burst of massive inflation that expanded to roughly 100 trillion times its initial size. After a few moments, the resulting plasma started to cool and the first subatomic particles began forming. During the first 20 minutes, atoms formed in this new fusion-fired universe. The cooling process left behind a space that contained around 75% hydrogen and 25% helium, roughly the composition of the modern sunday. The universe became opaque as electrons annihilated photons. Roughly some 380,000 years after the Big Bang occurred, the universe had cooled enough to form the very first stable atoms. Then as electrons joined the tiny atomic universe of atoms, photons began to release a background glow. This glow is what astronomers today refer to as cosmic background radiation. Astronomers believe that the consistency in this cosmic background radiation is why the universe inflated in this manner after the Big Bang to create the universe. Number 2. Stelliferous Era. The Stelliferous Era is also known as the Age of Stars. It was during this very active period that the majority of stars and galaxies were created. Stars are formed whenever a pocket of gas gets denser to the point it collapses in on itself. Heat is produced when this happens, and it triggers a nuclear fusion in its core. Processes like these are the primary source of current energy in the universe today. The very first stars created were massive, and they eventually exploded as supernovas. These explosions created millions of smaller stars which coalesced into galaxies because of gravity. One hypothesis that originates from the Stelliferous Era is that bigger stars burn up their energy quicker and then dies. This generally happens within a few million years. Conversely, smaller stars consume energy much slower and therefore are active for more extended periods. Stars and galaxies are always coming and going because of this inconsistency in burn rates and star sizes. As a result, many scientists believe that our Milky Way galaxy will eventually collide and join together with its neighboring Andromeda galaxy in roughly 4 billion years. Such an event would create a new megagalaxy that astronomers call the Milkomeda galaxy. While it is possible that our solar system could survive such an event, it probably won't survive the one after that. Some billion years after the galaxy collision event, the Sun will begin running out of hydrogen and start entering the red giant phase of its star life cycle. The Sun will become so massive that it will literally subsume Earth and its companion planets prior to shrinking down into a white dwarf star. Number 3. Degenerate Era. Next, we have the Degenerate Era, which begins about 1 quintillion years after the Big Bang and then spans around 1 duodecillion years afterward. This is the period where the current stars in the night sky will completely dominate the universe. This means that if we looked into the sky at night, the sky would be much darker, with only a few dim lights emitting from the remaining brown dwarfs, white dwarfs, and neutron stars. These are known as degenerate stars because they are much cooler and emit far less light than those stars we presently see. Sometimes, the corpses of stars will pair up in orbital death spirals that end with a flash of energy when they collide. Otherwise, the skies will be mostly dark. It is during this era that small brown dwarfs will possess the majority of available hydrogen. Black holes begin to grow massively as stellar remains feed them. Because of the widespread hydrogen deficiency, the universe will get duller and much colder. And then, as the protons begin dying off and dissolving matter, the universe is left with a bevy of unclaimed radiation in the form of subatomic particles, setting the stage for the next era. Number 4. Black Hole Era. The name of the next era, the Black Hole Era, pretty much speaks for itself. For a relatively long period of time, black holes will rule the entire universe as they pull in whatever is left of all its energy and mass. However, black holes do eventually evaporate very slowly as they leak tiny bits of their content. Scientists estimate that a relatively small black hole that contains 50 times the mass of our Sun would require around 1,070 years to evaporate. Whenever that last remaining black hole gives off its last bit of mass, a tiny burst of light emits the only remaining energy strong enough to be visible in the universe. Number 5. The Dark Era. The Dark Era begins when that last black hole has expired. At this point, the universe has pretty much run its course, and only a few very low-energy, weak subatomic particles and photons remain. The question at this point is whether or not these last few particles are capable of creating enough energy or emitting enough light to sustain anything. Some astronomers believe that the universe will still be expanding at this stage from the energy of the Big Bang, and is therefore capable of starting a new universe given the right conditions. Others believe that once the lights have been turned off, the universe is dead forever. Guess we'll never know for sure.